You are welcome to part 2 of probability, and in this video we are looking at rules of probabilities. So if you are new on this channel, kindly consider to like, subscribe and share. So without wasting my time, let's move real quick under the rules of probability. So we are looking at the first rule. That's rule number 1. The extent of what? Probability. The extent of what? Probability. So what do you mean by the extent of probability? Let's use some illustration to clarify that. Okay, so looking at this diagram, we have a rectangle and we have a circle within. The rectangle is being denoted by what? X, and the circle is being denoted by what? A. Right? So what does this two illustration mean? So let's say the X is a sample space. So I say that let the X be the sample space. So sample space. All right. The X be the sample space, and let the A2 be what? The event that will occur. Event. I hope that is clear. Now, if S is a sample space and A is the event, then we can say that let's represent the sample space by, say, the number of n. So we can say that let X, the sample space, be equal to the total number of what? The total number of, that's the sample space, represent as n. The number should be n, right? And that of the A2, which is n of what? The event, is also equal to, let's use that one as what? R, as I've indicated here. All right, so we have the R representing the event, and we have the n representing what? The sample. All right, okay. So now, if I want to find the probability that the event will occur, then I can say that the probability A will be equal to the number of what? The events, which is what? Number of A over the number of what? Sample space. I think we saw this in the classical probability. That's the objective view, if you remember. So if you are new here, kindly check the description section of this video. I've given a link to the first or the part 1 of probability that we are discussing. I've explained all these things there. You can check and then build your understanding from there and attend to this part. Or straight away you can still build, because it has been made so it will be made so easy for you to understand everything real quick. So thank you. So once you have the probability of A, it is the number of an event occurring over the sample space. I hope that is clear. So I can then say that this A, because we know number of A is what? R. So I can say that here is what? R. Then I say that the number of S, we know that one is also what? N. Small n. I hope that is clear. So I can finally say that the probability of an event occurring is what? R over what? N. R over N. But be with me here. Something's going to happen here. Just be with me here and then notice very well. You see, we are saying that the probability that an event will occur is what? R over what? N. So that is R over what? N. That's the probability of A. That's the event over the sample space, R over N. But you can realize, you can see that from the diagram, we can see that R is a subset of what? X, right? So we can make that inference that here, number of A is the subset of number of what? The sample space, which is what? X, isn't it? You can see in the diagram here, because out of the sample that the event will occur. Okay, good. So having gotten that, if that is true, then we are saying that since A is a subset of what? X, then it is very true that if probability of the event occurring, it is certainly that it is going to be what? Less than the sample space, which is what? The X. Because it is a proportion of what? The sample space that the event is what? Occurring, which is what? The A. And if probability of an event occurs, we have three approaches that you need to know. If an event should occur, there is a three approach or the three things that you need to know for an event to occur. So if an event A is occurring, then we can say that if it's occurring, then we can say that if an event A is occurring, the probability of an event A is occurring can be that either the event A, as number of A, would be less than the sample space. If it's occurring, it could be that it will be less than the sample space, or it could be that the number of what? The event A would be equal to the number of what? The sample space if it is occurring. Please, I hope that is clear. If it is occurring, it can be, the result can be that the number of events occurring can be less than what? The sample space. Or it can be equal to the sample space. Okay? Or it can also be, so once it's also less than the sample space or equal to the sample space, it can also be that the number of what? The event occurring can also be greater than what? 0. Greater than what? 0. Greater than what? 0. Okay? So if I want to combine these inequality signs and equations that I've derived, I can say that if I have my R over N, which represent the probability of what? A, I can say that if the chance of A occurring can be equal to 0 or can be less than what? Can be equal to the sample space or less than the sample space, I can have that one here. If it is less than the sample space, then it will be this. It will be number of what? X. And we know the number of X is N, so let me use N straight away here. N. Okay, so this one's cancelled. Or we are saying that it can also be equal to what? The sample space, which is the X. So I can say that if the event occurring is equal to the sample space, then I'll have the equal sign here. But then if it's less than the sample space, then it will be what? Less than this. So I can have this inequality sign being derived here. Please, I hope that is clear. Follow me very carefully. Or we are saying that the event occurring, once occurred, it can also be what? Greater than what? 0. So if it's greater than 0, I can say that it will be this. You have a greater than sign here, and you have your 0 here. Please, I hope that is clear. Good. But then, if the event is not occurring, the assumption is that if the event is not occurring, then the assumption is that the number of events not occurring will be what? Equal to what? 0. But this is not certainly what? True. It's not certainly true that an event not occurring is always 0. It's never true. I'll explain to you the reason why it's never true. Though for the benefit of explanation, we say it is equal to what? 0. But this is certainly not true in real life situations. The probability of an event not occurring is not true in real life situations. Let's say, for example, using an election as a practical example, if let's say we have, let me use that one here. If you let's say we have 1,000 population and we have party A, party what? B. And at the end of the day, party B wins the election with, let's say, 5,550. It means that part A didn't win, so you lose. So that means that the probability of party A will be what? 0, isn't it? But this is not true. We have 4,000 population and party B wins for 550. So meaning that the remaining 450 was for what? Part A. Though he couldn't able to exceed part B's vote. So the fact that A didn't win, the probability that he will win didn't happen, doesn't mean that it makes it what? 0. So that is the real life situation. Here you see it's 450. Is it 0? No, it's not 0. It's what? 450. So that's why I'm saying that it's not what possible. It's impossible to get probability of what, where in real life situation at what? 0. For example, taking the example that we are making here as an election, we have 1,000 population and the B win by a vote of 550. Does it mean that A had a vote of what? 0? No, it's certainly not true. But then, for the benefit of explanation, we conclude that if an event doesn't occur, if part A didn't win, then it is assumed to be what? 0. But I'm saying that in real life situation, it doesn't happen like that. This is never true in real practice or in real life situations. It's never true. So take note of that and be guided. Right. So having gotten, so I first explained that the probability of an event occurring will be that event will be less than its sample space. When it occurs, it can be that it will be less than its sample space, or it can be equal to its sample space, or it can also be greater than 1, 0. But once it's less than sample space, at least have a single value that will be greater than 0. Right? And the probability of no event not occurring is what? It's equal to what? 0. And I've explained the reason why it is 0 and not 0 in real life situations. You are aware of that, so take note. So if that is so, if you are saying that the probability of events not occurring is 0, then we can have the equal to sign indicate here. Meaning that here, when you have R over N equal to 0, means the probability of the event not occurring is what? 0. That is why we are deriving this equation. So it becomes 0 less or equal to R over N less or equal to what? N. And when it's equal to 0, the event is not occurring. That is assumption. When it is greater than 0, then the event has occurred. The event can occur when it can be greater than 0, or can be less than a sample space, or it can be equal to what? A sample space. I think we define those terms in here, so take note of them. That is the likelihood that events can occur in 3 ways. Either is equal to the sample space, or less than the sample space, or equal to the sample space, or greater than what? 0. But if not occurring, it is what? Equal to 0. That is the assumption that we are using, so take note of that. So now, if that is true, then I can say that if I divide both of the equation by n, this is what I'm happening. If I divide both sides by n, because I'm having n here, so I'll divide the remaining sides by what? N. What is happening? If I divide both sides by n, what is happening? Meaning I'm going to get what? 0 less or equal to R over N. Then when I divide n by n, I'm going to get what? 1. I hope you are following. Good. So now, having gotten this, therefore we can say that since R over N was equal to a probability of A, therefore we can conclude by saying that therefore 0 less or equal to P of A is also less or equal to what? 1. And the reason why we go through this, the extent of probability, is to determine the range at which probability occurs. So probability occurs at a range of what? 0 and what? 1. So this is how can we made that assumption. I can see some of the text videos say that probability of events occurring is in between 0 and what? 1. So this is the fact behind. So it becomes 0 less than or equal to probability of an event occurring less than or equal to what? 1. So if an event not occurring, it is assumed that it's 0. If an event occurs, it can be that it's equal to 1 or less than 1 or greater than what? 0. I think I defined those terms when we were explaining it in that case. So let's take note of it. So that's the rule number 1. Rule number what? 1. So let's take note of that. So let's go into rule number 2. Rule number 2. Rule number 2. So rule number 2, we're talking about what? Complementary event. Complementary event. What do you mean by complementary event? So let's use an illustration to also to clarify that rule number 2. So with complementary events, the idea is that now we have this sample space, a rectangle, then we have what? A circle. That is the event that will occur. Alright? Good. So now, what is the idea about a complementary event? The idea is that, let's say, let me use this A, because what is here, what is in the brackets, or what is within the circle is that an event will occur. Alright, so if it is outside, then the idea is that the event won't what? Okay, so let me use A bar, this A bar, to denote the event A. So the event A does not occur. The event A does not what? Occur. So let me use that to make. So if event A does not occur, then it will be A bar, it will be outside what? The probability that the event will occur, which is the R. Alright? Good. But we already know that the R was present as what? The probability that the event will occur, which is the A. And we use the N, which is this N, to represent what? The total sample space, isn't it? So if the probability that an event won't occur, which is the A bar, and that is what? The R. So that will be R bar, right? So that is, yeah. This R will be an event will occur, sorry. So within this cycle, any activity that will take place will make sure that event will occur. But if it's outside, then it will not occur. And we use N to represent the sample. So if the event won't occur, then it means that it is actually the total number of the sample space minus the event that will occur. So if I subtract the event that will occur within this cycle from the sample space, the remaining will be an event that won't occur, and that's what we call what? The complement what? Event. Complementary what? Event. That's what I mean by what? The complementary what? Event. So what is the probability that A won't occur? A won't occur. The probability that A won't occur will be what? P of A bar, which will be equal to, and we are saying that in that, if A should have occurred, it should have what? Been R over what? N, isn't it? As we did here, R over what? N. But here, since it won't occur, we are going to take into account the total number of the sample space that we have. Then we take away the event that will occur within the sample space. Then we divide by the total samples, which is what? The N. Please, are you following? That is the whole idea about complementary events. So let's take note of that. So we started by saying that if R is the event that will occur and N represent the total sample space, then if the probability that an event R will occur, then that one will be what? R over what? N, that's the sample space. But then if R won't occur, then it means that it is a complementary. What will add to the R that will occur, that will give us the total sample space of 1, is what we call the complementary event. So the complementary event is basically the one that will complement or I'll add up to the event that will occur to make a sample space of 1. That's what I mean by complementary event. So here, the event that A won't occur will be the event that the R will occur minus the total of sample space. And that's why you denoted here. Then divide by the number of sample space, which is the N. So let's take note of that. So now having gotten this, therefore we can say that the probability of A not occurring, that is R not occurring, I can break it down by saying that here is N over N minus R over what? N. I can do this breakdown. And it's the same thing as this. So I can say that, therefore, the probability of A not occurring, what is N over N? Is what? 1. Alright? Minus R over N. But we know R over N was present at probability that an event will occur, which was what? Probability of what? A. So therefore, we can say that the probability of an event not occurring, which is the A, will give us what? 1 minus the probability that an event will occur. And that is how come we derive this formula. So anytime you are given a probability that an event will occur and you're asked to find the probability that that same event won't occur, it is actually 1 minus the probability that event will occur. And that's why you have denoted here. In that case, please, are you flowing? That is the whole issue about complementary events. It is actually the probability that will occur, taking into account minus what? The probability minus 1 minus probability that an event will not occur. That will give us the probability that an event won't what occur. And this is how can we derive this formula. So you may see in most of the books is a anytime probability of an event won't occur, it is 1 minus the probability that an event will what occur. That's how can we derive this formula. So that's the whole deal about it. So let's take note of that. So here is an example to clarify the complementary event. All right. So here is our example goes. A marker is drawn from a box containing 15 blue, 10 black, and 10 yellow markers. Find the probability that the marker is A, yellow, B, black, C, not black. So how do you undertake this? So first thing I need to do here is first of all look at your sample space. And the sample space, the total outcomes. The total event is a total event, yes. So that's the sample space. So the total event will be 15 blue, black, and then 10 yellow. So I'm going to add, so my sample space will then be 15 plus 10 plus 10. And that will give me what? 10 plus 10 is what? 20 plus 15, 35. So 35 markers, right? 35 markers. And then requirement A is what? Find the probability that the marker drawn is what? Yellow. So the probability of what? Yellow will be equal to the number of yellow marker in the box divided by the total what? Markers, which is a sample space of X. So I can say that what was the yellow marker? Yellow markers, it was what? 10. So 10 divided by what? 35. Alright, so your result will be true. So 10 out of 35 will give you what? 2 out of what? 7. And you are good to go. B. The probability that the marker drawn is black. So here too, probability of B will be equal to the number of what? Black markers divided by total or sample space X. And that will give me, so a black marker within the box was what? 10. Same thing divided by what? 35. Okay. And then going to get the same result, which is 2 out of what? 7. I hope that is clear. Then the last one, C. It is saying that we are to compute for not black. So if it is not black, that is where the complement event rule number 2 comes in, of probability comes in. So if it's not black, then it won't happen. If it's not black, then it won't happen. Okay. So if it's not black, then it becomes probability of not black, which is what? B complement. B bar, sorry. And that will give me 1 minus the probability that black will occur. And we know that probability that black will occur has been calculated as what? 2 out of 7. And the result is true. So we're going to get what? 5 out of 7. Let me check and see whether it's true. So 1 minus 2 out of 7. Yeah, I had 5 out of 7. So that is very true. And that's so this is how the complement approach works. So let's take note of that. So that was just by the way with rule number 2 with complementary events. So we are moving on to rule number 3. We talk about either or situations. Either or situation. How do you find a probability with the word either or? Once you heard of the word either or, neither nor, either or, neither nor, we mean the union of the two events or more than event. Because we say an event is basically a collection of one or more sample outcomes. So here, once you heard of either or neither nor, we mean the union of the events. The union of what? The events. So for example, if I have an event A and what event what B. If I have an event A and event B of an what of a same what experiment, then you are saying that the two experiments A is either or. It is certain that A will either occur or B will occur. So once I heard or, either or, the idea is that the two events are into union. So the probability will be A union what? B. And once you heard of A union B, the expanded version of A union B would be equal to the probability of what? A plus the probability of what? B minus the probability of what? A intersection B. Because we want to get what? The union of what? A and B alone. So we do away with the intersection. Please, are you following carefully? Once you heard of what? Either or. Once you heard of the or attached to the either, this is how the way it becomes union. Please, are you following? So this union too can also be, as I was saying, we can make the language explanation that it is probability of A or what? Or B because of the or. And with the or, we mean the union between the two events. And that's what I've defined it here. So if, for example, we have, let's say, 3 events, A, comma, B, and let's say C. How do you also take into account using either or situation? That one too will be probability of A or B or C will be equal to, first, the probability of A plus the probability of what? B plus the probability of what? C minus, realize that when we're doing the 2, we're doing A union B, we take the intersection of what? Probability of A intersection what? B. So we're going to subtract all the intersections minus probability of A intersection what? B minus the probability of A intersection C minus the probability of B intersection what? C plus all the intersection of the 3 sets, because you have subtracted all the individual when we are taking them into two events. But here we are taking them into threes. But we assume that when you are taking them to twos, we will subtract what the intersections of these two events from probability of A plus B, right? Or probability of A, B, or C occurring. That's what we're actually doing here. So here, once we subtract all, we then add the final intersection of all the events, which is what? A intersection B intersection what? C. So that will be the whole deal. So anytime you get either or situations and you are asked to find the probability for such a situation, it becomes what? Union. And as I've indicated, this is the same thing as probability of A union B union C. They are the same thing. Okay? So once you get of this, just add probability of A plus probability of B plus probability, and then subtract their relative intersection if assuming we are to treat them as two events as it is here. Alright, then add their final intersections for all the events. You add them to it, then you get that probability in that case. So let's use an equation to clarify this rule so that you understand it better and appreciate it well. So let's go to solve a question on that. So this is an illustrative question example for rule number 3. Let's see. In a group of 30 students, all study at least, please take note of this, at least one of the subjects, critical thinking and psychology. 20 attend critical thinking class and 21 attend psychology class. Find the probability that a student chosen at random studies both critical thinking and psychology. Please, when you heard of at least in probability, we mean a number and above. We mean what? A number and above. And it's a similar situation in either or situations. The same, or it happens if they don't bring the word either or neither nor, they can also bring what? At least one of the subjects. Means that it's going to be a total. If we are saying that at least is a number and above, it's going to be the total of that number itself and any other number that is above that number. That's what we call what? An at least. And it's linked with either or situations. So let's take note of this, because at least we can get at least one person or one student that study one of the subjects, then there wouldn't be any problem. So let's see how we undertake that question in that situation. So first, okay, let me present it here so that you appreciate it all. Let me have my solution here. So let's see. So what is my total sample space in this question? Is for 30. So I can say that my number of x is equal to what? 30. Right? Then my number of the event CT occurring is what? CT 20, I think 20, sorry. And my number of the event psychology is what? Let's say X. Yeah, let's say P is what? 21. Okay. And so since the question said at least one of the students, at least we can get one student study the critical thinking and psychology class, psychology as a subject, then it is an either or situation, meaning that we can at least get every student, at least a single person, or at least every student will be studying all the subjects. So it becomes what? An addition, all of them. So once all of them study that subject, then we take into account the union of what? The two subjects and the student that studies such subject. Please, are you with me? That's what we mean by the at least one of the subjects. So we are going to add. So it becomes what? So it means we are going to use this approach. It becomes the probability of what? CT or what? P. This is the same thing as what? Probability of what? CT union what? P. And realize that will give us, if you are to expand this, you give us probability of what? CT. Probability of CT plus probability of what? Psychology is P minus probability of the intersection of the two, which is what? CT intersection what? P. That will be the whole approach that we need to consider in that case. But one thing we need to note here is that the requirement of the question is find the probability that a student chosen as random study both what? Critical thinking and what? Psychology. So once you hear the word both to in probability, we mean what? An intersection. So we are going to find this. Actually, CT intersection what? P. Once we hear and both between two or more events, we mean what? Intersection. Please take note. Once you hear and both between two or more events, we mean what? Intersection. So kindly take note of that. So we are going to find the intersection of this, but then we go by the either or approach to derive the equation that we solve. So the probability of A or B occurring, critical thinking or psychology occurring is a union, all right? So what is be the union? So here it's going to be, so we can have this equation as here because of the equation. That's how I bring it here so that we see it clearly. So here I can say that probability that CT union P occurring with what? 30. That's the union. The question gives to us sample over what? 30, and is equal to, what is the probability that CT occurring? Also what? 20 over what? 30. P occurring 21 over 30. Let's represent it by, let's say, X. Okay, so I'll make S a subject. The final answer will be true. All right. Okay, so when I make the S, I'll be getting 20 over 30 plus 21 over 30 minus 30. Of course, I've made S a subject. So my final answer then going to be 11 over 30. You can use the calculator to check and see whether it is true in that case. So that is the rule number 3 on either or situation that we have actually encountered. So once you heard of at least, then you are thinking of either or, then you use this approach to expand to get whatever the question requires you to solve. So therefore we can say that the probability of CT intersection P is equal to 11 over what? 30. 11 over 30 in that case. So let's take note of that. So this is where we bring an end to part 2 of our probability discussion that we are going through. If the video was helpful to you, please consider subscribe and like so that we can get more engagement on this video to help other students who may also be interested in this kind of video. So I will see you in the next video where we continue with the rules of probabilities in that case. So thanks for watching. Bye bye.